Welcome to all. Now we are going for this is engineering mechanics. I think class 46. I don't exactly remember. Anyway, in the title etc. you can see it. Part 2. That is equilibrium, types of loads and support reactions. There, lecture number 5 I think most probably. Okay. What you are doing today is application of basic conditions of static equilibrium for a coplanar force system in general. See, in coplanar, 3 types are there. One, concurrent. Second one, one more last is parallel. They are outer side. In between, general. General means random. See, for concurrent, there is a condition. All forces should meet at a point. So it is concurrent coplanar. Parallel, once again coplanar, but all forces, line of action of all forces should be parallel to each other. But general means no restriction. It should be in one plane, that's all. No need of, there is no question of concurrent or parallel. So general. First, I'll give some note for you. Today's class is perfectly, or it's a perfectly, I can tell, thoroughly concept based. I will explain it later, why concept based. First, take the question. Question 1. For the given force system, find the value of P1 and P2. Question is here. Little small I written. You can zoom and see. Anyway, later a big sketch is there. P1 and P2. Oh, where is P2? I forgot to write P2 only. P2. Here. P2. I forgot to enter P2 only. Okay. Distance is 150 millimeter. All in millimeter now. Force are in Newton. Distance in millimeter. P1 and P2 for equilibrium. Okay, now, solution. Class. I will dictate something now. First, for thoroughly understanding, what you do is, before you start in solution, you write the requirement is, find the value of P. Now see, red color. I have changed red color. Now you can see this question. You have to find the value of P1 and P2 for equilibrium. So, make a note. There are 2 unknowns here. So, I use red color for unknown. As usual, usually unknowns I use red color. There are 2 unknowns here. This side here, okay. 2 unknowns. Namely P1 and P2. Now come to basic conditions of static equilibrium for coplanar. For a coplanar force system, there are 3 basic conditions. 3 basic conditions. 3 basic conditions of static equilibrium, namely sigma fx0, sigma fy0, and sigma m0. Therefore, only 2 unknown, 3 conditions are there. Actually, this question is given in an examination. I don't want to tell where, somewhere it is given. So anyway, we will first solve. Then I will come to concept. Okay, start. Solution. Class. First do one thing. You show correctly xx, yy. Somewhere you have to show it. Okay. Let it be xx. Let it be yy. Okay. That you always show it. Understood. See, class. Unknowns are P1 and P2. So right there, we have 2 basic conditions. See, this question, there is no inclined force because there is a reason for it. I will tell you later. Reason. Next question, I will give inclined forces. Okay. But today's class is a concept-based question. Okay. First, for equilibrium, you should, what all I tell, you have to write it. Otherwise, it will be incomplete. See, those who are serious, they will write everything I tell. As I told you, in the class, I am dictating important concept, whereas notes I am writing it. For equilibrium, for a coplanar force system in general, there are 3 basic conditions of static equilibrium. Right? First one, sigma fx0. Explain further. Algebraic sum of components of all the forces along xx equal to 0. Correctly right? Here I am putting only, see, later, sigma fx0. Explanation I am telling now only. Those who are serious, I told, write it. Next, second condition. Sigma fy equal to 0. algebraic sum of components of all the forces along y equal to 0. Okay. Sigma fx, sigma fy, two conditions. So you can solve P1 and P2. But there is one more condition. Sigma m equal to 0. Right here, sigma m equal to 0. One more condition is there, right? The third condition is, I think space problem is there. I should check it there. It should not go out of camera sometime. Yes, no, it's okay. The third condition is, see, first one, sigma f, see, right somewhere. First condition, sigma fx 0. I already explained. Second one, sigma fy 0. Next, third condition, sigma m equal to 0. Very important, right statement. Algebraic sum of moments of the entire force system about any point. No restriction. You can take moment about any point. This all I explained earlier. I should not repeat it, the same thing again and again. Equal to 0 are three conditions. Now, you write one more note. But in this question, only two unknowns are there, P1 and P2. So, sigma fx 0, sigma fy 0 are sufficient to solve. Therefore, we will solve. Okay. Right. Sigma fx equal to 0. Right side positive. Plus P1, then plus P1 minus 100 plus 40 minus 30 equal to 0. P1 equal to 90 Newton. Plus 90 Newton means correct. It is to the right side. It is what direction given is correct. Next. Sigma fy equal to 0. Take upward positive. Unknown first. Minus P2 minus 60 plus 150 minus 20 equal to 0. Solve it. P2 will come plus 70 Newton. Yes, direction is correct. Now, class, I will dictate. Therefore, in the question, they asked us to find P1 and P2 for equilibrium. Yes, we got it by using sigma fx 0 and sigma fy 0. Therefore, the answer is P1 equal to plus 90 Newton, P2 equal to plus 70 Newton. Okay, write that much. Now, be careful. See, I wrote something here. Also, see, given question is wrong. I deliberately set a wrong question because somebody may comment. They may tell this person does not know subject. How you can give P1, P2 unknown only? It is not give equilibrium. I will tell, I know it. Given question is wrong. I will explain later. Now, time has come for explaining why later. Right here. Now, after everything, now some statement I am giving here, right here. The given question is a wrong question. If it is a question given in an examination, the person who set the question does not have basic knowledge. Yes, that is the comment I have to pass. When people do not know that much concept, see, the most critical, if that is not known for them, simply blindly they ask you what is P1 and P2 for equilibrium, they are not fit to set any questions. Leave alone teaching, they leave alone questions and also teaching. Now, what is the mistake here? First of all, in the question, distances are given. Have you used it? No, not used it. Then why they give distances? But they can tell, my wish, I can give distances. If you do not want to use it, you don't use it. See, sometimes what happens is, they give extra data. If it is not required, don't use it. They will tell that way, do not use it. Okay, agreed. But now the concept is, 1 minute. Now the concept is very important. We found P1, P2 for equilibrium. There are three basic conditions of static equilibrium. Three basic conditions, namely sigma fx 0, sigma fy 0, and sigma m about any point equal to 0. Now, is this condition used? No. That is a mathematical blunder. Is it applicable? Yes, applicable. See, if it is not applicable, leave it. See, in concurrent force system, we are not used sigma m equal to 0 because it is not applicable. All the forces are passing through one point. There, two unknown is correct. In concurrent force system, two unknown is correct. Two unknown, two conditions. But here, two unknowns, but three conditions. If it is a structural analysis later, the structure will become unstable structure. It is nonsense. Here, what is wrong? See, we got P1. You should write everything after the class. We got P1 and P2. Now, what is the guarantee that sigma m equal to 0? What is the guarantee? Is there any guarantee that sigma m equal to 0? No. Therefore, what we will do is, we already applied sigma fx 0, sigma fy 0. Now, we will apply that sigma m 0. We will not apply sigma m equal to 0 because there is no unknown. What we will do is, we will find, see right here, what we will do is, we will find sigma m about any point of our choice, any point. Say, we will take, see, I will take A, B, C, D. In the question not given, say A. Usually people want A. Okay, start. Now, I will start that one. See, now remember, right here, by this time, you know the value of P1 and P2. Very important. By this time, you know the value of P1 and P2. Okay, now, right here. Now, but they want value of P1, P2 for equilibrium. Now, it is, see, since they told it is for equilibrium, this force system should be in equilibrium. They are not told force equilibrium. Okay, now, let us find sigma m, algebraic sum of moment of the entire force system about A with the clockwise positive, equal to, with the clockwise positive. Considering everything, known, unknown, etc. Okay, take moment about A. See here. Start from here. 40 into 0. I'll start from there. 40 into 0. 100 into, this is 300, this is 90, this is 210. First of all, this I should not explain. So, anti-clockwise, minus 100 into 210. Plus, whatever is that P1, see, whatever is that P1 into 300. Why? It is clockwise. Substitute P1 equal to how much? We got 90 Newton. This P1 we got plus 90 Newton. Substitute it. Then, moment about A, plus 60 into 220. See, 60 into 220. Plus 60 into 220. Plus P2 into, this is 500, this is 150. So, P2 into 350. Plus P2 into Y plus clockwise into 350. And later substitute P2 equal to plus 70 Newton. Equal to plus 70 Newton. Okay, then minus 30 into 100. Minus 30 into 100. Plus 20 into 170 plus 120 is 290. Plus 20 into 290. Minus 150 into 120. Minus 150 into 120. Let me check once again. 1 minute, I will check once again. Minus 100 into 210, minus whatever 0, minus 100 into 210, plus P1 into 300, plus 60 into 220, up to where over? Okay. Plus P2 into 350, minus 30 into 100, plus 20 into 290, minus 150 into 120. If you calculate, this will come, I already calculated, because plus, it will come plus 28500 Newton millimeter. Oh, right here. Therefore, what I am explaining now, you write. You should write. Here, see, I told, those who are serious, they should listen. Therefore, the question where we are asked to find P1 and P2 for equilibrium is completely wrong question, because what P1, P2 you got by sigma fx0, sigma fy0, two conditions, there is one more condition to be satisfied. sigma m 0, it is not satisfied. When you take moment about A, I got plus 28500 Newton millimeter. That is what? That is sigma m about A equal to 28500 Newton millimeter clockwise. Suppose you get negative, write anti-clockwise. This all you know it. I should not repeat it. Okay. Now, only for concept, we took moment about A. Somebody will ask in the class, so instead of moment about A, sir, suppose you take moment about B, what will happen? Okay, take, do one thing, I won't write. See, take moment about B, I am not writing. Right there, instead of sigma m about A, suppose you find sigma m about B. Okay, I will explain now. Start. From here, minus 20 into 210 anti-clockwise. Okay, plus 150 into 380. Why? 500 minus 120. 40 into 0. 100 into 210 anti-clockwise. P1 into 300 clockwise. Minus 60 into 280 anti-clockwise. Minus P2 into 150. Why minus? Anti-clockwise. Then minus 30 into 100. My guarantee, even when you take moment about B also, even when if you find sigma m about B also, it will come plus 28500 Newton millimeter. Okay. Or just somebody will tell, sir, so okay, take opposite corner, take moment about C. Just do one thing. Also do one, just these are all for practice or concept. Find sigma m about C. Okay. Take clockwise positive, clockwise positive. Now distance all will change now. See. Take moment about C. Start from here. Minus plus clockwise. Plus 30 into 200. Why 200? 300 minus 100. Okay, then minus 20 into this distance, that is 210. Plus 150 into 380. Minus, now 40 is not into 0. When you took moment about A and B, 40 into 0. But now 40 into 300 anti-clockwise minus plus 100 into 90 plus P1 into 0. P1 into 0. Then minus 60 into 280. Why 280? 500 minus 220. Minus P2 into 150. I think all are over. If anything is missing, consider my guarantee. I'll calculate. See? That it is not coming, subject gone. Plus 28500 Newton millimeter. Therefore, write a note. Therefore, write a big note. Now, you should write something. I am removing all this one now. I am removing all. I remember, it is there. I noted the answer. Okay. Now, write a note. Important note. Once again, given in the given question, we are asked to find unknowns P1 and P2 for equilibrium. It is a coplanar force system where, in general, there are three basic conditions of static equilibrium, namely sigma fx0, sigma fy0, and sigma m about any point equal to 0. Of course, since only two unknowns are there, we easily got it by using sigma fx0 and sigma fy0. Answer came, but that is a wrong question because that value of P1, P2 you got will not satisfy sigma m equal to 0, because when we consider moment about any point, we took about A, we took about B, about C, or about D, or about any point you take, you will get a clockwise net moment of 28500 Newton millimeter. Now, why moment about every point came same? Think a little. See, sigma, I will give the reason for it. Sigma fx0, algebraic sum of horizontal forces equal to 0. Sigma fy0, algebraic sum of vertical forces, sorry, not horizontal, xx and yy equal to 0, because horizontal vertical later, 0. Therefore, there is no resultant force. That is guaranteed. If there is no resultant force, only possibility is if there is no resultant force for a coplanar force system, you cannot tell blindly that system is in equilibrium. For system to be in equilibrium, resultant force should be zero, resultant in the form of force should be zero, resultant in the form of couple also should be zero. So there is every chance that resultant, this I told long back, can be in the form of a couple. And I told earlier, if the resultant is in the form of a couple, then moment of that couple is same irrespective of whichever point you consider. Or for the complete system, actually this will actually reduce to a couple. There are so many couples will be formed here. See, net vertical forces, all vertical forces will create a couple, horizontal forces will create a couple. When a couple is created, net force equal to zero, moment will be there. Moment of a couple is constant. That's why when you check moment about A or B or C or D or any point, you mark outside also. Moment will come 28500. Therefore, you should put a comment. The given question where you have to find P1, P2 for equilibrium is nonsense question. Then I solved this one to understand the concept, so that when you study equilibrium, first question I want to encounter the real concept. Therefore, for equilibrium, sigma m should be zero. Therefore, what mistake the person made who said the question? Somebody will tell, sir, you only said the question. Yes. Now imagine I have not said. See, but I told wrong question. When I give a question and tell it's a wrong question, it is not said by me. Someone said the question. Okay. Therefore, don't tell me I have said the question. The person who said the question, he should improve his structural knowledge. Structural knowledge. How? He should know when three unknowns are there, when three conditions are there, there should be three unknowns. See, if three conditions are there, if there are three unknowns, yes, you can solve. Later, we will call determinate. If three conditions are there, but unknowns are more than three, that is okay. You cannot solve by using conditions. Later, it will become statically indeterminate. But for three unknowns, for three conditions, if two unknowns are there, it is nonsense. So number of conditions should be, or number of unknowns should be either equal to conditions, good, or it should be more. More means you can't solve using conditions. It can't be lesser. So at any cost, unknown cannot be less than conditions. Therefore, now right here, therefore, a person who knows the subject, who has at least minimum knowledge, okay, leave around minimum knowledge, at least minimum knowledge of structure, knowledge of basic concept of structures or engineering mechanics, what he should have done is, he should have given the question some other way. Okay, now I will tell you, now given question wrong, gone, now I will modify the question. Now, question modified. Okay, 1 minute. Question modified. Okay. For the given force system, find the value of P1 and P2, and also a couple to be applied. A couple to be applied for equilibrium. Now question is correct. For equilibrium. Okay. This is a modified question. See, now question is, for the given force system, find the value of P1 and P2. How many unknowns? Two unknowns. And also a couple to be applied for maintaining equilibrium. So now unknowns, right? Now you should write unknowns are three. One. You should write P1, second one, P2, next one. Some unknown couple to be applied. Okay, start. Once again, same way, solve and get P1, P2. Okay, now, once you get P1, P2, okay, now see, P1, P2 you got. Now, start. Now, to find couple to be applied anywhere. See, a couple you can apply anywhere in the plane, applied for equilibrium. For equilibrium, let us find right here algebraic sum of moments of the entire force system about any point, say A, that is sigma m about A, equal to, take clockwise positive. Some will tell, sir, how you know about A? See, if you want to apply a couple, when the forces vanishes, see now sigma fx 0, sigma fy 0. So resultant force vanished. So only couple is possible. If couple is possible, I told so many times earlier, moment of the couple is constant irrespective of whichever point you consider. You already know it. So now correctly calculate. See, just now I explained how much about A. If you remember, minus 100 into how much? This is 210, etc., etc. Little earlier I explained. So correctly write once again, everything write once again. Everything write once again. Write answer equal to plus 28500 Newton millimeter. That is 28500, correct, Newton millimeter clockwise. Okay, still not over. So one statement you have to write. So given force system, this system is or has equilibrium if you consider forces in sigma, if you consider net resultant force in x direction, resultant force in y direction, equilibrium is maintained. But the equilibrium is spoiled or it is not there because the given force system will reduce to a couple of clockwise couple of 28500 Newton millimeter. It will the complete given force system will reduce to a clockwise couple of 28500 Newton millimeter. Therefore, you are right here. Therefore, for equilibrium, be careful. For equilibrium, I told you the given couple will reduce to a clockwise couple of 28500. I told long back, anybody can tell what to do. Sorry, apply anti-clockwise of 28500. Or long back I told, a couple can be balanced only by another couple of same magnitude but opposite direction. Write the statement. For equilibrium, the question, a couple of how much? 28500 Newton millimeter anti-clockwise is to be applied. Wherever you want in the plane. Right here. Apply wherever you want in the plane. One anti-clockwise couple also. See the couple, the system, apply one anti-clockwise couple of 28500. Now what will happen? The given force system will rotate the body in clockwise direction of 28500. This applied couple of 28500 anti-clockwise will balance it. Now sigma m equal to 0. Okay, this is one aspect. Or right here, one more thing. Suppose they do not, now see, once again, question once again modified. Original question modified. Original question again modified. You should write all these if you want to understand. Original question once again modified. How I will modify? I will tell you now. How I am going to modify now? See. First of all, make a note. How I am going to modify the question? 1 minute. The question is, for the given force system, same question. Question is, or modified question, remove now. Modified question is, for the given force system, find the value of P1 and P2, that's all, for equilibrium. P1 and P2 for equilibrium. P1 and P2 for equilibrium. Now what I am doing is, see, I am writing question now. X. Oh, now correct. Unknown. X. That means, right here, they want to find value of P1, one unknown, value of P2, second unknown, and also you have to find where P2 is to be applied. Where that P2 is to be applied, that also you have to calculate. You have to calculate where that P2 is to be applied. Okay. Therefore, now right here, now, okay, this is remove now. Now, if you see question correctly, there are three unknowns. Three unknowns. Which one? Namely, P1, comma, P2 and X. Oh, correct. Now, okay. Therefore, okay. Why? Three unknown and three basic conditions of static equilibrium. Sigma Fx0, sigma Fy0, sigma m equal to 0, about any point. Any point. Okay, now three unknown, three equations you can solve. Okay, solve the question. Start. First, write the question. Now, don't write 150 here. They want it to be X. Okay. X. Okay. Now, sigma Fx0. Once again, solve the question. If you want to learn everything, once again solve. Sigma Fx0. Same answer. P1 is plus 90. Sigma Fy0. P2 is plus 70. Now, write here. Now, write last condition. See, now, to get X, next condition. See, sigma Fx0, sigma Fy0, next, and lastly, sigma m equal to 0 about any point. About any point, whichever point you want. Anyway, let us consider sigma m about any point. A will do. Okay, A equal to 0. Take clockwise positive. Actually, if you take about A, P2 into 500 minus X will come. But if you take moment about B or C, P2 into X will come. So, better B or A or C, B or C. Anyway, leave it, hardly matters. Okay, take A. If you take moment about A, now see, now you are not finding sigma m, you are applying the condition. You are not finding sigma m now. We want sigma m to be 0. What value of X is required? So, take moment about A, minus 100 into this distance, minus 100 into 210 plus P1 into 300, P1 into 300, okay, P1 I will put red color, P1 into 300, for P1 substitute how much? Plus 90, for P1 substitute plus 90 later, plus 60 into 220, plus P2 into, see, moment about A. This is 500, this is X into 500 minus X, 500 minus X, P2, then all over, minus 30 into 100, 30 into 100, plus 20 into 290, plus 20 into 290, lastly, minus 150 into 120, 150 into 120, equal to 0. Solve, you will get the value of X will come. X will come in millimeter. You will get X in millimeter. Let us calculate that value. I have not calculated. Shall I pause? Okay, no, I will calculate in front of you only. What is there? I have not calculated. Okay, I start from here. This term, all this term will go, I will first calculate all the terms. Minus 100, calculate is not on, luckily. Minus 100 into 210 plus 90 into 300, 90 into 300 plus 60 into 220. I will leave this one now. Minus 30 into 100 plus 20 into 290 minus 150 into 120. Answer is coming plus 4,000. I will take it to other side, plus 4,000 into minus 1. It will go to other side. That will be equal to P2 into 500 into X. So P2 into 500, I will take that side. So plus means minus, minus P2, 70 into 500. Left hand side, now I have got minus P2 into X. So I will divide by P2, divide by 70. It will give you 557 point. I got doubt about this answer. Let me see. Okay, I got 557. 5 plus will come. 1 minute. I'll check the answer once again. I will pause and check. Plus 557 point 1428. 1428 571 millimeter is the answer. Plus or yes, plus. That is the answer I am going to get. Now, I will, instead of wasting time, I do not want to give wrong answer. I will pause the recording, check this value once again, then I will tell you a trick to find out. For those who have got capacity, you can find it by using a trick also. I will tell you it later, but I will pause and first check this answer. I do not want wrong answer. Because sometimes, whatever way I calculate, see, human being, calculation mistake, I am helpless. Everybody can do it. Okay? Perfectly correct. That is the answer. Now, but one important here, you got plus 57. Plus means what? See, positive means our P2 from with respect to C, it is considered to left side. Positive came, so left side. But answer is 557.142857 means the P2, see, from here to here is 500. Therefore, the P2 should be acting where? The P2 should not be acting here. See, this is the point C. Your P2 should be acting here. P2 equal to how much? Your P2 equal to 70 Newton should be acting at, it should go further left side, total 557.1428571 millimeter. Or from A, it should be how much? 57.14, etc., etc. If you want, you can write the answer. But X equal to, got it. Now, make a note. Make a note. You took moment about A. Instead of that way, if you take moment about C, little easier. Why easier? Because then you get directly P2 into X. Okay, right. If you take moment about C, minus P2 into X, minus 60 into 280, plus 100 into 90, minus 40 into 300, plus 150 into 380, okay. Now what happened is, when I told I will check and then pause and start, I paused there, came here, explained something else. Then when I went there, recording was not on, it got closed. So I am re-recording now. Okay, no problem. See, this is perfectly correct. I checked it. So this is the answer. That is, by taking moment about C, you got the answer. But make a note. You can take moment about any point. When you took moment about, moment about A you took. See, this is moment about A, not C. When you took moment about A, we got P2 into 500 minus X. It is better to take moment about C. Okay, right here. Or, it is better to take moment sigma m about C equal to 0, clockwise positive. See what will happen. Right. Minus P2 into X, minus 60 into this distance, that is 280, plus 100 into 90, plus 40 into 300. I remove that 300 here. It's rubbed down. See, this height is 300. Remember? Okay. Then plus 150 into 380 minus 20 into 170 plus 280 290 210 minus 30 plus 30 into 200 equal to 0. My guarantee x will come same, plus 557.1428571. Just to check it, because when a system reduces to a couple, then moment about which point you consider has no effect on the answer. See, when you find reactions later for beams, etc., sigma m about any point you can take. So therefore, whichever point you take, answer will come same. Okay, now what is the meaning of here? See, therefore, the P2, which earlier they told wrongly at 150 is a wrong question. So now see, P1, P2 and x, three unknowns are there. X came plus. Plus means what? You should write it. You found the point C, P2 is to left side. Positive came, correct. But from C to D is 500. So we got 557. Therefore, that P2 should be where? You can make a note here. Actually, that P2 should be beyond A. See here. That means if this is C, this is 500. See, this is 500. Your P1 is correct. See, your P1 will be there only. See, your P1 is here only. P1 equal to how much? P1 equal to 90 Newton there only. Your P2 should be, see, somewhere here. Your P2 should be, red color I will put here. Your P2 equal to 70 Newton. From C, it should be how much by 557.1428571 millimeter. Or from A, it should be 57.1428571 millimeter. That is the answer. See, if you got by chance less than 500, correct, P2 will be between C and D. By chance you got negative, make a note. If it is negative came, then that P2 should be not left side, it should be somewhere other side. See, instead of left side here, X you got negative means it should be that side. Make a note. If you get negative, write P2 somewhere here and to that distance X without sign. Okay, now I told a trick if you want. This trick is not advisable to everybody. See, not advisable. Only those who can afford and understand the concept, they can go for it. See, what I will do is, suppose if I am solving the question, somebody tells me, find P1, P2 for equilibrium, and he will tell you this distance is 150. This distance he will tell 150. Imagine somebody is asking me to solve a question. Okay. He will give 150 here and tell find P1, P2. I will tell immediately to him, your question is wrong. I don't have to think. Two unknowns, three conditions, impossible. Then he will tell, but anyway, he will tell force equilibrium. Okay, I will tell P1 90, P2 70, but wrong. Wrong means not P1, P2 wrong, question is wrong. Then he will tell, correct. Do one thing. Don't take 150, he will tell, take it as X. Now he will tell, now unknown is P1, P2 and X for equilibrium. Now I will tell him, yes, now correct. Find it. What I will do is, when I found moment about C earlier, when C, this is actually for those who can understand, when P2 was, how much P2? P2 is 70 and this distance was given 150 mm at that time, moment came 28500. 28500 clockwise, Newton millimeter. Now, I will remove that P2 came because it is P2 into 150 anti-clockwise. So, because of, now I will do one thing now, that P2 is 70 into 150 anti-clockwise is 10500 anti-clockwise. I will remove that term. So, I will add, why remove? Because when it is an anti-clockwise, it came 28500. If it is not there, sigma m would have come plus 28500. 390000 Newton millimeter. Now that will be equal to P2 into X. So I will divide by P2 70 and check the answer. 557.1428571 28571. Remember, such concepts or such imagination, such tricks you can apply only if you got mastery on the subject. I am not telling I got mastery. Yes, I got mastery. Why should I hide it? It is a known fact. I got complete control on the subject with no blemish, nothing, no confusion. Nowhere in structural engineering I got one single doubt regarding the basic concepts of. Therefore, you can solve that way, but don't try it. Try only if possible. Now I thought, see here, P1, P2, X they've asked. Or they can do one thing. They can ask P1, P2 at a known distance, 150 only, plus one more they can give, say P3. Then okay. Then 3 unknown, 3 conditions you can solve. But I won't solve for today because then P1, P2 will go, vanishes. Some other value will come. That, see, today's class question is a concept-based question. Question number 2, I will go for that one where I will include inclined loads also, solve another 2 or 3 more problems for coplanar, then go to parallel force system. Then there are so many questions for equilibrium. You have to go to Lami's theorem, then some contact surface, normal reaction. So many things are there. We will start one by one. Okay. Now, next class I will continue for same thing, application for coplanar continued, question number 2. Okay, thank you.